The most immediate problem? Repairing a weakened impoundment levee dating back to the early 1900s. The 60-acre impoundment sat near a creek first diverted and created by the coal company, a tributary to a major river. However, the impoundment was structurally unstable because of how it was built.
That was the very first part of the levee. After the slurry pond became full, this is again 50 years ago, they took coarse material or gob and raised it up another 10 or 15 feet.
A sudden failure would have sent a huge discharge downstream that likely would have damaged property or injured or killed people, the very thing the AML Fund is designed to address. Gob material, consisting of coal and spoils, was exposed in the tailing ponds, and that contributed to ongoing acid mine drainage in the nearby creek. The highly acidic water also penetrated the levee, holding back the sludgy mix, making a breach a distinct possibility.
We could have breached the levee and slurry could have went into the mud creek, and it would have been very difficult to stop at that time.
Project managers had 3 goals in mind for the site: repair the levee, reclaim the coal, and fix the acid mine drainage. The biggest obstacle to doing all 3 was geography, a cramped, small site that would hamper moving heavy equipment around. So project engineers chose to take that cramped layout and use it for their own purpose. They needed room to create a bioreactor. To clear some land, they pumped more than 6 million gallons of acidic water out of the levee, treated it, and then placed the clean water into the nearby creek. From there, they took the slurry and stacked it away from the levee. They removed coarse material from the dam and replaced it with more dense soil, strengthening the levee and making it less likely to breach.
Stacking slurry, I honestly wasn't sure that it would stand up like they said, but that's, engineers get paid for being engineers, but it was just an incredible process.
At the same time, the engineers moved more than 70,000 cubic yards of substrate to create the bioreactor, a combination of 17,000 tons of agricultural lime, 2,400 tons of compost, 4,000 tons of wood chips, and 5,000 tons of hay and straw, all designed to act as a natural filter. The bioreactor takes in water from the stream that drains the slurry, and also from a nearby gob pile. Water coming in is highly acidic, water going out almost completely alkaline, and the iron and manganese concentrations are much lower. And the impact of this project also spilled over to an active mining site. Peabody Mining allowed the AML team to store substrate materials on Peabody's permitted area while construction was going on. Peabody also benefited, and so did the environment, when the company saved money by using the same contractor as the AML project to treat another acidic area. Finally, the team finished the site using geomorphic techniques to make the site not only functional but aesthetically pleasing.
The serpentine ditch was a challenge, but obviously that works out good and it looks good from an aerial photograph standpoint.
The judges cited the use of the bioreactor as an emerging technology, the consolidation of the slurry into a smaller site, and the geomorphic design in awarding the Mid Continent AML Award to the Indiana Department of Natural Resources.